This is the last section of Chapter 9. We're not doing 9-9. This is on the final exam, so you definitely want to start this as well. Partial fractions. Here's how case 1 ends up talking about math language. So what partial fraction decomposition is that you are going to take, well, this is a good one to start with. Look at that. What we first need to do is we first need to factor the denominator into linear factors. Oh, I need something skinnier. I'm going to take out an x squared out of the front, the negative out of the back. And then that can double bubble. So there's my 3 linear factors. The denominator actually could be rewritten like that, which is what I'm going to do. 3 linear factors, x plus 1, x minus 1, x plus 2. If they are linear factors in the bottom, meaning it's just an x or whatever variable we're doing, but we're going to use x, they become a, b, and c's on top. So we're finding 3 values to go on top. Now, normally, when we want to combine fractions, you multiply like this first fraction right here, by the denominators of the other two so that they have common denominators. So a is being multiplied by x minus 1 and x plus 2. I'm going to have to move this over because it's going to end up being really long. So I want b to be multiplied by the other two denominators, which is x plus 1 and x plus 2. And then c is multiplying x plus 1, x minus 1. I'm actually going to distribute all that stuff out. X squared plus x minus 2. B is x squared plus 3x plus 2. And c is x squared minus 1. So I'm going to reorganize it. I'm going to put all my, well, we'll do it step since it's new. We'll distribute ax squared plus ax minus 2a. Bx squared plus 3bx plus 2b plus cx squared minus c. Okay, now I need to reorganize. Here's an x squared. Here's an x squared. Here's an x squared. So my x squareds, there's an a and a b and a c. A regular x, a regular x. They were pink. Plus x. So a plus 3b. And then we have things that don't have any x's at all. And they just go at the end. Minus 2a plus 2b minus c. Okay, on the numerator, right? Because we were working with a, b's, and c's. That's what it should equal. It should equal 13x plus 17. Okay, there is no x squared term, so this is technically a coefficient. So a plus b plus c equals 0. There's a 13 here in front of our x, so this should equal 13. A plus 3b equals 13. And then our back part, our 17, should be what this equals. So the last part will equal the 17. Move this down a little. Negative 2a plus 2b minus c equals 17. Nope, yeah, that's right. Now you have a matrix again, your system. 3 variables, 3 equations. Solve it, just like any other system. When you do your partial fraction, once you get all this work, because it's a lot of work, that part right here, you can do in the calculator. That's fine with me. So this ends up coming out to be a is negative 3, b, oh no, that's not true. A is negative 2, because my numbers are backwards. A is negative 2, B is 5, and C is negative 3. So this is so crazy because I should have left more room. This is really equal to negative 2 over x plus 1 plus 5 over x minus 1 minus 3 over x plus 2. And if you actually try to combine those 3 fractions together, you will get this original function. If we have linear factors that are repeated, so we need lots of room for this. Okay, so this is how it goes. So the first factor is an x, so put an a over it. Next factor is an x minus 1, put a b over it. Then it goes x minus 1 squared, put a c over it. Then it goes x minus 1 cubed, and put a d over it. So this ends up equaling a would multiply by the x minus 1 cubed, b would multiply by an x and an x minus 1 squared, c would multiply by an x and an x minus 1, and then d would multiply by an x, which this does expand. I'm going to need write it back here. A equals, oh, A does not equal anything. X minus 1 cubed expands to x cubed minus 3x squared plus 3x minus 1. Then next to B, we have x cubed minus 2x squared plus x. Next to C, we have x squared minus x, and then an x next to D. Remember, I am reordering this, so all my cubes go together. One there, one there. So a plus b. Then my x squareds are next. Let's see here, another color. Here's one with the a negative 3a, a negative 2b, and a c. Then we have x's. Here's a 3a, a b, a negative c, and a d. And then for our numbers, the only thing left is right here, that negative a. All right, so this is supposed to technically equal the top, which is 6x squared plus 6. Okay, well, there's no cube term, so this piece equals 0. This piece equals 6. There's no x term either, so this piece equals 0, and negative a equals 6. Okay, well, if negative a equals 6, then a equals negative 6. And if a plus b equals 0, and a is negative 6, then b is positive 6. If negative 3 times a, which is negative 6, minus 2 times 6 with b is 6 plus c, and that's supposed to equal 6. A lot of 6's. C ends up being 0. And the last part, 3 times negative 6 for the a, plus 6 for the b, minus 0 for the c, plus d equals 0, and d is 12. So our actual, oh, that's really far. Our actual fraction comes out to be negative 6 over x plus 6 over x minus 1. Oh, c is 0, so there's no 0 term, so plus 12 over x minus 1 cubed. This will be a long one. Well, maybe not. Then if we have quadratic factors on the bottom, first you have to factor this. That's the number one rule. Factor the bottom. So this comes out to be x squared plus 4 with an x on the outside. So this is going to equal a over x plus, but when you have quadratic factors on the bottom, then you have linear factors on top. Okay, so we're still finding an a, b, c, but when there are quadratic on the bottom, it's a linear factor on top. So a is missing the x squared plus 4, and then bx plus c is missing the x. So distribute that in, distribute that in. Okay, so this should equal the numerator, 11x squared minus 2x plus 24. Well, x squared terms are supposed to equal x squared term. So 11 equals a plus b. Then an x term, cx, is supposed to equal negative 2x. Oh, I don't need the x's. So c equals negative 2. And then 4a equals a 24. So a is 6. I plug this back in. B is 5. So my actual fraction is negative 6 over x plus 5x minus 2 for the bx plus c over x squared plus 4. On the bottom. Now, all we're doing is writing the form of this. We're not actually solving this one because this one's crazy. So this is linear, this is quadratic, linear, but there are repeated values. Okay, so which means we start with an x plus 1. But because it's a repeated value, we do x plus 1 now squared. And then we do x squared plus 2x plus 30. But because it's a repeated value, now we do x squared plus 2x plus 30 squared. Oh, we're not done because it goes to the third. X squared plus 2x plus 30 cubed. And then the last one is an x minus 2. So anytime the bottom has linear factors, it just needs to be a regular letter. A, B. We'll save that one at the end because we'll go in order. Then we have x squareds. So this is going to be cx plus d for a linear. Ex plus f. Gx plus h. And that'll be an I. And that's how you set it up. Last one. The first thing to do, remember, is to factor to see if anything can cancel. Now this, oops. I don't think that's going to help us with the top. But they do divide out. You can do the top into the bottom because this is to the fourth and this is to the third, so we're going to have to lose long division. All right, x cubed goes into 3x to the fourth x 3x times. We're going to multiply through. Boy, minus 36x. Those go away, those go away, those go away. Negative 27 minus 36 is 9x plus 22. So this is a remainder. Okay, so this actually equals over okay. This we don't touch right there. We're not going to touch that. But this is actually what we're going to do the decomposition on. All right. Well, I just factored it up above. They are all linear, so A, B, C on top. So A is missing the x plus 2 and the x plus 3. B is missing the x minus 2, x plus 3. And C is missing the x minus 2 and x plus 2. I'm going to multiply by foiling. All right, and then regroup. So we have x squareds. X's. And then values. Okay, so this is going to equal 0 because there's no x squared in the numerator. This is going to equal 9. This is going to equal 22. So the system would look like this. And remember I told you once you get to this point, just stick it in the calculator, go to reduced row echelon form, tell me what A, B, and C are. And A, B, and C are not the same order as mine. So my A will equal 2, B will equal -1, and C will equal -1. So this fraction, what it equals, remember there was a whole part, which is 3x plus 2 over x minus 2 minus 1 over x plus 2 minus 1 over x plus 3. And that finalizes chapter 9. Yay!